Hello students, this is the second class of chapter number 1, that is number. Okay, and in this video we will learn LCM, HCF and prime factorization. How we can find LCM, HCF and prime factorization of any number, right? So are you ready for this class? Let's start to solve some question. Okay, so the first question on your screen, express 4020 as a product of its prime factors. So we have to do prime factor. That's it. So we have two methods, right? One you could say a ladder methods, that is this method. You can write 420. Choose a number who can divide 420 without getting any remainder, right? So we will start basically from 2. Yes, so 2. Let's check. Because here you can see the ones on in ones place we have 0. It means it would be divisible by 2, right? So that's why I am 100% sure this is divisible by 2. 2 2s are 4, 2 1s are 2, and then 0. Again we have 0 in ones place, so it means again it is divisible by 2, right? So let's divide. 2 1 is 2, 2 times 1 it's 2, and 0 and then 5. Why here we have 0? Once again let me show you. When we divide 210 by 2, so see, 2 1s are, or you could say 2 times 1 it's 2, right? Here we have nothing after subtraction. So first we will bring down the number 1, right? And this is 1 is less than 2. So how many times we can go? In 0 times, right? 2 times 0, it's 0. And then if we subtract 1 minus 0, it is 1. Again, we have to bring down the second number. The second number is 0. Now we can go with 5. 2 5s are 10, or 2 times 5, it's 10, right? Now, you can see here why this is 105, not only 50, okay? And then, by what number we can divide? See, the addition of 1 plus 0 plus 5. Add all 3 units. It's a 6, and 6 is fully divisible by 3, right? So that's how we can divide by 3, right? So 3 3s are 9, 3 5s are 15, okay? And now add again 3 plus 5. This is 8, and 8 is not fully divisible by 3, right? So choose any other number. 3 after 3, 4, 5. Yes, 5. In how many times? 7 times, and then 7, right? In 1 times. We have to get this 1 in the last. Now you can write 420 equals how many times we have 2? 2 times. 2 times 2, and we have 3 1 times, 5 1 times, and 7 1 times. That's it. Okay. So that's how we can find out the prime factorization of this number 420, right? Next, find the LCM of 18 and 30. Right now we have to find the LCM. So here we can use the same method as we solved this one, the ladder method, but now I'm gonna use a different method that is called tree method, right? By tree method, I'm gonna solve this question. Suppose here we have 18 and here we have 30. So by what two numbers we get what times what equals 18? So obviously 2 times 9, right? 2 times 9 equal 18. And now, can we divide 9? So what times what equals 9? Obviously 3 times 3, right? So see the bottom numbers. They are prime numbers, right? So for 18, we have 2 times 3 times 3. Or you could also write 2 into 3 to the power 2 or 3 square, right? Similarly, what times what equals 30? 2 times 15, right? We cannot, do factor of 2, but we can factor this 15. What times what equals 15? 3 times 5. So again, what we are getting? The prime number in the last. So 30 we can write as a 30 equals 2 times 3 times 5. If you want to check our answer is correct or not, our factorization is correct or not, so you can again do multiply. 2 times 3, it's 6. 6 times 5 equals 30. Yes. Okay, so it means our factor is 100% correct. So here we don't have any number repeating. So the LCM is what? LCM is equals what? Choose the highest power. So first there are 2, 3 and 5. Here we have number 2. Here we have number 3. But here the power is higher. Okay. And here we have 5. So which 2 we will pick? 2, as we can see, the same power 1. But which 3 we will select? The highest power. So the highest power on 3 we have 2. And again the 5. We cannot leave any single numbers, right? Why we are skipping this? Because it has no highest power. That's why we are skipping this 3. But in the place of 3, we are taking 3 square, right? So after calculating it, what we are getting? 90. That's our answer. Moving to the next. Okay, find the HCF. Now here we have to find HCF. Let me know what is the full form of HCF, right? So by what method you want to solve it? Okay, I'm gonna solve it by ladder method, right? 48. You can choose by tree method also, but you will get the same answer, okay? Your answer will be the same, even you are choosing the ladder method or the tree method, right? So obviously in the unit place we have 8, so it is divisible by 2, fully divisible by 2, right? 2 2s are 4, 2 4s are 8. And again we have in units place 4, so it means again it is divisible by 2. 2 1s are 2, 2 2s are 4, 2 6 times, 2 3 times. 1 second. 2 3 times, 3 1 times, right? Similarly for this 18 0. So because in unit place we have 0, so it means it is fully divisible by 2. 2 9s are 18 and 0 as it is. Again we have 0 in ones place, so 2 45, right? You have to just do half. Now in ones place we have 5. Now 4 plus 5, how much it is? 9. And 9 is fully divisible by 3 or not? Yes. Now come with 3. 3 1s are 3, 3 5s are 15. Again with 3, 3 5s are 5 1s are. Okay. Now we have to find the HCF, not LCM, right? So how can we find the HCF? How many 2's are there? 1, 2, 3, 4. For 48. For 48, we have 2 to the power 4 times 3, right? And for 180, how many times we have 2? 2 times. How many times we have 3? 2 times again. And 1 time 5. See the difference in LCM and HCF. In LCM, we take the highest power, right? But in case of HCF, we take the lowest power. So we will start from the 2. As you can see, which one is the highest power? 4 or 2? Obviously, the bottom one, 2 to the power 4. Because we are finding the HCF, so we will consider the lowest power. That is 2 to the power 2. Now, moving to the next number, that is 3. 3 here we have with power 1. And here we have 3 with power 2. So the lowest power is what? 3. Okay? 3. And see, here we have 5. But in case of 48, we don't have any factor 5. Right? Here we don't have any factor 5. So we will not consider this 5. Okay? This is your answer. 2 2's are 4. 4 3's are 12. This is what? The HCF of this given number. Moving to the next. The question is, the LCM and HCF of two numbers are this and that respectively. It means this one is the LCM and that one is the second one is the HCF. Okay, if one number is 12, find the other. So we have a formula, you could say the first number multiplied by second number equals LCM times HCF. Okay, with the help of this formula we can find easily. So put the value and get the answer. If one number is 12, so suppose the first number is 12. Okay, now we have to find the second number. LCM is given by 84 and the HCF is 4, right? So second number is what? Second number equals 84 times 4 divided by 12. Okay, can we cancel 84 by 12? Yes, we can. In 7 times, right? So 7 times 4, how much it is? 28, right? So the second number is what? Second number is our 28. Okay, and you can recheck. Multiply by 12. Okay, how can we recheck? Multiply first number by the second, and LCM is 84 and the second HCF is 4. If you are getting left hand side equal right hand side, it means your answer is correct. Okay, check it now and let me know your answer is coming equal or not. Okay, moving to the next. Here, what you have to find? Find the LCM. But here we have 3 numbers, as you can see, right? 12, 15, and 20. And these are very, short numbers, small number, we could say. So we can, do factor very easily. No need to apply any tree method, any ladder method. Okay. We can just simplify by this. 2 2's are 4, 3's are 12, right? Or we could write 2 to the power 4 means how many times we have 2? 2 times. So 2 to the power 2 and 3. The next number is 15. So 3 times 5. That's it. 3 times 5. Nothing else. 20. 20. 2 2s are 4. 2 times 2 and 5. How many times we have 2? Power 2 and the 5. Right? Now, what we have to find over here? This is the main thing. LCM, right? LCM. In case of LCM, what we will consider? The highest power or the lowest power? Absolutely, we will consider the highest power. And you can see in the first and in the bottom number, we have 2 to the power 2 in both the cases. And both are the highest or equal, you could say. Right? So we will write 2 to the power 2, and then we cannot skip any single number in case of LCM. What comes after 2? 3. So which one is the highest power? 1, 1. Both have the same power. 3. So just copy and paste it. And 5 is also there. Right? It doesn't matter. This 5 is not in the first row. Okay? This is not over here. It is completely okay. But we cannot skip any single number in case of LCM. Now, 2 to the power 2 is what? 4 times 3 times 5. 4 times 5 is 20. 20 times 3 is 60. 60. So the LCM is what? 60. Yes, there you go. Now, moving to the next. Find the HCF. Now here we have to find the HCF. And again, we have 3 numbers over here, right? So I'm gonna apply ladder method, right? And this is up to you. If you want to apply the tree method, this is also okay. You will get again and always the same answer, right? So 36, by what number we can divide? We will start with the 2, because we know that in one space we have 6, so it is 100% divisible by 2. After dividing by 2, we are getting 18. Again, it's a 9. Again, by 3. 3 3s are 9. 3 and 1. Right? This is for 63. The second number we have 60. This is for 36. Sorry. Okay. So the next number we have 60. 60, because in one space we have 0, it means it is divisible by 2. So after dividing, we are getting 30. Again, it's 15. Now it's time for 3. 3 5s are 15 and 5, 1. Good. Now the third and the last number we have 72. Right? So in the ones place we have 2. So obviously it is divisible by 2. 2 3s are 6. 2 6 are 12. 2 18s are 2 9. Now it's time for 3. 3 3s are 3 1s are. Okay. Now good. Now I'm gonna write this in proper way. 36 equals how many times we have 2? 2 to the power 2 and 3 to the power 2 again, right? Both have power 2. Both have double number. And in case of 60, 2 to the power 2 and 3 and a 5. And what about the 72? For 72, we have 2 to the power 3, right? 2 to the power 3 and 3 to the power 2, right? And now, most important thing is what we are finding. We are finding the HCF, not LCM. So for HCF, what we have to do? We have to consider the lowest degree, right? And if it is common in all three numbers, then we will count it. Otherwise, no. Right? So 2 to the power 2, 2 to the power 2, 2 to the power 3. This is common. The 2 series is common in all three numbers. Then we will write 2. But the power is the lowest one. Right? 2 to the power 2. Okay? Now moving to the next number. The next common number, this is 3. 3 to the power 2, 3 to the power 1, 3 to the power 2. This 3 is coming in all three numbers, right? In this one, that one, this one. But you have to choose the lowest one. So which one is the lowest? 3. And 5. What about 5? Why we are not considering this 5? Because 5 is only present in 60. It is not in 36, neither in 72, right? If it is not in all three numbers, so we cannot consider the number 5, right? In case of LCM, we can, but in case of HCF, we cannot. So this is our HCF. That's it. 2 to the power 2 is what? 4. 4 times 3 is 12. So the HCF is 12. That's it. I hope you are getting now. Moving to the very interesting topic. I mean the question, are 35 and 48 co-prime? So what do you mean by co-prime? You should know first what is the meaning of co-prime. So co-prime basically co-prime numbers whose HCF equals 1, right? It means there is no any common number except 1. Suppose 3 and 7. In 3 and 7, if we factor, suppose 1, 3 and 1, 7. So what number is common in 3 and 7? Obviously 1. So this 1 is what? Is common in both numbers. So the HCF is 1. Okay, if the HCF is 1, it means 3 and 7 both are what? Co-prime numbers, right? Good. Now, similarly, we have to find out the co-prime numbers for 35 and 48. So, in case of 35, do factor 7 and 5. Am I right? Yes, I am. And we cannot simplify more than this. So, I am leaving it over here. Moving to the second number, that is 48. 12 times 4, right? And we can also continue 4 times 3. Yes. And 4 means what? 2 times 2. And this is also 2 times 2. So what is the prime factorization? The bottom number, the last number. 2, 2, 3, 2, 2. Okay. And here what we have number? 7 and 5. So is there anything common? I mean any number is common in between 35 and 48? No, right? 7 is in 35, but 7 is not in 45, right? 5 is also in 35, but 5 is not in the 48. Similarly, if I see very carefully, here we have 2, 2, 2, 2, 4 times. But in case of 35, we don't have any single 2, right? And we know very well for HCF, we have to, we have to see at least one pair. It must be, otherwise we cannot consider HCF, right? Similarly, for the 3 is 1, 3 is there in case of in 48 series, but in 35 series, we don't have any single 3. So we cannot take common, or we cannot consider HCF, right? So you could say there is a nothing common in between. Nothing means we can say here we have one number is common, that is 1. Except 1, there is nothing common. Okay? So here we have HCF equals 1. If the HCF is only 1, it means both. Both means what? 35 and 48. Both numbers are what? Co-primes. And we have justified it. Okay? I hope this video would be useful for you, right? And if you have any kind of query, any suggestion, so please let me know in the comment box. I will try to sort out as soon as possible, right? So that's all for now. See you in the next class. Till then, take care and thanks for watching.